The internet. It feels like it's just there, right? Like the air we breathe. But the network that you're using to watch this right now, well, its origin story isn't about connecting friends or building businesses. Nope. It was born from a single, terrifying question that kept the most powerful people on the planet up at night.
What if a nuclear attack happens? That was the real question. Not how can we share vacation photos, but how can we possibly communicate after the bombs fall? The quest to answer that question is what accidentally changed the world forever.
So our story doesn't start with innovation for innovation's sake. It starts with pure, raw geopolitical fear. This is part one, a start from fear. You really have to picture the scene here. The Cold War is at its peak. In 1949, the Soviet Union gets the bomb. Then, in 57, they launch Sputnik, and that just sends a shockwave through the US. So America responds by creating DARPA, a high-tech agency with a simple mission: build the future and make sure America owns it. And then, in 1959, a brilliant engineer named Paul Baran joins a think tank and spots a weakness in America's defenses, a potentially fatal one. And here it is. This was the critical weakness. See, back then, all communications, military commands, phone calls, everything ran on a system called circuit switching. It's that model on the left. Everything had to pass through big, centralized hubs. Barron's chilling realization was that if an enemy bomb takes out just one of those hubs, the whole network dies. The solution he proposed on the right was a decentralized network, no central point of failure. If one path gets destroyed, information just, finds another way around. So Baran takes this game-changing idea to DARPA, and out of that Cold War pressure cooker, a project is born: ARPANET. This was the very first version of his decentralized network. It was the seed, the single seed from which the entire internet would eventually grow. Okay, but building a network of roads is one thing. You still need rules for the traffic. And that was the next massive problem they had to solve. Which brings us to part two: information in pieces. The early ARPANET had this huge bottleneck. A single wire could only handle one stream of data at a time. Think of it like a one-lane highway during rush hour. It was just impossibly slow and inefficient. For this network to be actually useful, it needed to handle a whole lot more traffic, all at once. And the solution they came up with was just genius. It's called packet switching. Instead of trying to send one giant, continuous block of data, they decided to break it up. It's like, imagine trying to shove a giant ice cube down a skinny pipe. It's not going to work. But if you smash that cube into thousands of tiny ice chips, they'll flow right through. That's exactly what they did with data. They broke it into these small, easy-to-send packets. So this solved the traffic jam, but it created a whole new kind of chaos. I mean, what happens when all these little data chips get to the other side? Some might get lost along the way, some might show up late, and the ones that do make it could be in a completely random order. Your message would just be gibberish. To sort out this digital mess, the network needed a rule book, a universal language that every single computer could speak and understand. And that leads us to part three: the internet's own language. A couple of computer scientists, Vint Cerf and Robert Kahn, basically created this language. The first part is IP, or Internet Protocol. The absolute best way to think about it is as a mailing address. Every single one of us little data packets gets a unique digital address slapped on it, telling the network exactly where it needs to go. No more lost packets wandering around the system. But knowing where to go is only half the problem, right? The second part, TCP, Transmission Control Protocol, is what solves that out-of-order mess. So if IP is the address on the envelope, think of TCP as numbering the pages of the letter inside. It makes sure all the packets have actually arrived, and then it puts them all back together in the right order: page 1, page 2, page 3, so the final message makes perfect sense. So, by this point, we have a strong, reliable network, and we have a language for it to speak. But it was still unbelievably complicated to use. It was a tool for rocket scientists, not for regular people. So how did it get from the lab into our homes, into our hands? That's part four: the world at a click. Just try to imagine using the internet like this for a second. To go to a website, you had to memorize its numerical IP address, a long, clunky string of numbers. There was no Google, no way to search for anything, and you couldn't just click a link to jump from one document to another. The power was there, but it was completely locked away. And then one guy solved all of these problems in one brilliant stroke. a researcher over in Switzerland named Tim Berners-Lee. He had this vision for a way to make all this incredible information accessible to, well, anyone. He created 3 things that became the foundation of the entire web as we know it. First, HTML, the language we use to build web pages. Second, HTTP, the protocol that lets you click a link on one page and instantly jump to another. And third, the URL, which gives every single page its own unique, easy-to-remember address. Put them all together, and what do you get? The World Wide Web. But honestly, the most important decision he made was what he did next, which was absolutely nothing. He didn't patent it, he didn't try to sell it, he just released his invention to the world, completely free and open source. That single act of generosity is the reason the web exploded from a tiny project into the global force it is today. That beautiful utopian vision of a free and open network for everyone has, well, it's run headfirst into the hard realities of the 21st century. And that brings us to our final part, Part 5, the game of power and control. Okay, first, a major reality check. The internet is not some magical cloud. It's not floating in the air. It is a physical thing. A network of over 1 million kilometers of fiber optic cables running along the bottom of our oceans, physically connecting the continents. It's real. And because it's real, it can be controlled. And this physical reality is at the center of today's biggest power struggles. You have China, which uses its Great Firewall to decide what its citizens can and can't see, blocking sites like Google and Facebook. North Korea takes it a step further. Most of its citizens can only use a state-run intranet on a state-run operating system. And in the US, we've learned through leaks about massive government surveillance programs that monitor the data flowing through these very cables. This puts global tech companies in a really tough spot. For instance, after Yahoo complied with a Chinese government request and handed over a journalist's data, which led to him being jailed, a U.S. judge hit them with this devastating line. He said, "Technologically and financially, you are giants. Morally, you are pygmies." It just perfectly captures that massive conflict between corporate interests and human rights. So, as a reaction to this global tug of war, a new idea is gaining a lot of traction: data sovereignty. It's this simple but powerful idea that a country's data, your data, should physically stay inside its own borders, protected by its own laws. It's basically a digital shield against foreign control and surveillance. And that really brings our whole story full circle, doesn't it? A network that was designed by a government to maintain control was then given to the world as a tool for freedom and openness. But now, governments and corporations are in a massive battle to regain control over that physical network and all the data that flows through it. And that leaves us with the single most important question for the internet's future. Your data, whose control?